Hello and welcome to CloudChamp. In this video, I am going to explain Terraform right from the basic. Watch this video till the end. By the end of the video, you will understand all the Terraform concepts like variables, outputs, meta arguments, modules, remote backend, and all the things that you need to know about Terraform. So watch this video till the end and let's start. So before you learn Terraform, you need to have good knowledge about AWS Management Console. In AWS, we create our infrastructure or architecture. You can launch EC2 instances, create your S3 buckets, create RDS database. When you use your console, you dashboard, and then you click on things to create anything you want. But Terraform is based on IAC concept or infrastructure as code concept. You have the various tools like Terraform. For example, there is CloudFormation by AWS. Then you have Pulumi, which is another IAC tool. But Terraform is one of the tools which is used a lot, and because it has a lot of advantages, we're going to see what it is. So it is infrastructure as code, where you write your infrastructure or your architecture in the form of code. And Terraform is widely used because it is supported by all these different clouds. In Terraform, you can call them providers. So if I show you the list of providers, you have AWS, Azure, GCP, a long list with 2,744 providers. So with Terraform, you can work on AWS, on Azure. You can also work on Kubernetes, Helms. I will show you an example where we will be using Helm and Kubernetes in Terraform. So these are all the different providers. Let's say you want to create something on AWS, then you will be using AWS as a provider. If you want to create Azure cloud resources, you will use Azure. Same for GCP. So let's say I want to create EC2 instances. I'm going to go to AWS, and you can see all these different versions present for the provider. This was published last 10 days ago. This was 14 days ago. So there can be a criteria or a possibility where people are going to ask you to use a specific version. If that's the case, you can use a version. If not, you can go with the latest one. So if you want to use this, you're going to click on this option here, use provider, and you will get the code in this form. So this is known as Terraform block, and this is known as provider block. I'm going to explain the HashiCorp syntax where it will be easy for you to understand. So when you use Terraform block, you can define what version do you want. So right now it's set to 4.48, which is the latest one, but you can add any version value inside this to use any specific version. Okay. Then this is provider block, which defines that AWS is a provider, and we can then add configuration options like alias or region, anything. So infrastructure as code is a concept where you define your architecture or your infrastructure in the form of code, and then when you run the commands, it will be applied to your cloud resources. So you have different tools like Pulumi, Azure templates, CloudFormation, Google Cloud Deployment Manager, Terraform, all of these. So what is the benefits of using IAC concept? So it improve customer experience, increase speed, better documentation, scalability, more reusability, better collaboration, less human error, all these different benefits. And there is a confusion between infrastructure as code and configuration management as a code. There are two different things. If you see Terraform, and then here's an example of Ansible, which is most used tool. So Terraform is used to create infrastructure on the cloud. It's not used to, let's say it will be used to create EC2 instance. But if you want to install Apache web server or any database, you will be using Ansible to do that, because it is configuration management tool, and this is infrastructure provisioning tool. So here you can see infrastructure as code is the managing and provisioning of infrastructure through code instead of using manual process to configure devices. So instead of using your cloud management console, you can use Terraform, and this way you can reuse the code. These are all the benefits. You can reuse the code, you will have less errors, it will be very fast. Using commands, you can provision everything in seconds, and you can store it on your source control management like Git or GitLab or GitHub. So this way you can reuse your code again and again. And why is Terraform mostly used? Because it supports all the different cloud. If you use CloudFormation, you will only be limited to AWS. If you use Azure, you will only be limited to Azure. But if you use Terraform, you can work with all the different multi-clouds. Okay. So configuration management is another thing, which is configuration as code is the practice of managing configuration files and repository. Config file establish the parameters and settings for application, server processing and operating systems. So you will use this when you want to install or configure something on the cloud. you will use this to provision it. First you will provision and then you will configure. Like the example I gave, you will create an EC2 instance, and if you want to set up, let's say, WordPress or any Apache web server, you will use Ansible for that. There can be a possibility where you can use Terraform for that as well, but that's not recommended, because the primary objective is to create infrastructure, not manage it. Like for example, I'll be explaining you something known as provisioners in Terraform, where you can use to install something or run some commands on the server as well. So if you don't have Terraform installed, you can visit this website, and then you can install it. You can install it in Windows, Mac, Linux. This is commands for Linux because I'm using Ubuntu. If you're not using Linux, you should start using Linux, because cloud is based on Linux. You will be using commands to configure every DevOps tool you come across. Like Docker is based on commands, Terraform is based on commands, Kubernetes, everything is command based. So you need to understand and have experience with Linux. So this is how you will install Terraform. You can find the information on this page as well. And Terraform uses something known as HCL, or HashiCorp configuration language. So this is similar to JSON and YAML, but not exactly that. It is HCL, and HCL has a syntax like this. This is an example of instance, an AWS instance, which is web server. AMI is this, and instance type is this. So this is example of HCL syntax. And before we have already seen what are providers. You can define what providers you want. AWS, if you're using AWS as a cloud, you have to define this as a provider, right? Same for GCP, Azure, or anything. Then inside, after you define providers, if you want to create anything, you will define that in the form of resource. So for example, if I show you any code here, alright, can you see my screen now? So whenever you create something, first thing you do is define a provider. So this is how you define a provider. And we are using two providers here because we are creating some stuff in US East one and then in US West one. So I'll explain you that later on, how to define alias. Yeah, so when you use multiple regions in a single provider. So this is what a resource block is. If you want to create anything, it can be EC2, it can be security group, it can be subnet, VPC, elastic IP, anything. You will be defining that in the form of resource, right? So these are all the different resources, and then let's see the basics of how you can define a resource or a provider, which is in HashiCorp language. So you have a block, and then you have parameter, and inside the parameters or inside the block you will have key and value pair. For example, here you can see there's a resource named as local file, and then you have some parameters. These are the two parameters. This is what is the actual name of the resource, and this is the name you give inside for Terraform purpose, for Terraform references. And inside this block, resource block, you will have key and value pair. So key and value all the time. So here is the resource block, then you have some parameters, and this is key value. Okay, so you can see here, this is the block name, local file is the resource, it is the resource type, this is the resource name, then arguments are your key and value arguments. So here is some example. This is an example of creating a AWS instance resource, and here is an example of creating S3 bucket resource. So you have defined this as a resource type, and this is a resource name, arguments, AMI is this, instance type is this. So once you create this, then you need to run some commands to manage this. So let's go and create a directory and do this hands-on first. So I'm going to create a directory. Let's say learn Terraform. Okay, so can you see this? Is it visible for you? Okay, just a second. क्या हुआ? मैं काम कर रहा हूँ अभी. Okay, so I'm here in my Visual Studio Code. We have created a directory named as learn Terraform, and we will start creating some infrastructure on our cloud, on our AWS. To do that, before you need to run a command named as AWS configure, where you will enter your keys, access key and secret access key. You know what those are, right? Hello. So in AWS, when you create a user, IAM user, you can give them CLI access, and when you give them CLI access, you get keys. So these are secret access key. Yeah. So these secret access key and access keys are used to log in through CLI. You can run the command AWS configure, and then you can enter your access key ID, then secret access key, then the region name, and then the output format. And this is how you will connect it. If you want to check, you can just run AWS IAM list dash users, which will give you the users present in the IAM. So if these are the same, which means you're using the correct account, or else there might be a chance where you might be using your company's account, which you don't want to do, right? So inside this directory, I'm going to first create a file named as provider.tf. Every file should end with .tf in Terraform, because that's how Terraform works. Every file should be with .tf extension. So inside this provider.tf, we are going to define our AWS provider. So I can go to the documentation, which is here, and I can copy this code, paste it here. So this is Terraform official documentation, and if you want to do anything, you can use this, and you should always be using this because it's a good practice to follow documentation. This way you will avoid making any issues. So you can see this documentation will give you all the examples on how you can set up your own provider. You can also type anything. Let's say you want to create EC2 instance, so EC2 instance and then Terraform will take you to the Terraform documentation. This way you can use this as a reference to create anything. So here is the resource block for AWS instance. You can use this to create anything in your account, like the AWS instance. So using the documentation, we got this Terraform block, which is using the latest version, and then you have a provider named as AWS. Inside this, I'm going to add an argument, which is going to be region. So I'm going to use US-East-1. So this is North Virginia, also named as US-East-1 inside our AWS. So okay, no problem. Alright, so here are the different versions. If you want to cross check, make sure you're using the right name, which is US-East-1 North Virginia. If you want to use any other else, you can use this names from the console. So I'm going to add this, and once you add this, then you can create your infrastructure. I can choose to create EC2 instance right in this provider.tf, but I'm going to create another file, name it ec2.tf, or you can name it anything, main.tf, server.tf, anything you want. So I'm going to go to the documentation again. A lot of tabs are open. Alright, so I'm going to copy this block of code, resource AWS instance, and then paste it in our code here. So we are not using data block here, so I'm going to remove this and provide my own value. So resource is AWS instance, and this is the name of the resource. AMI value, I'm going to put that from the console. Instance type is T3 micro, and the name of the instance should be hello world. Okay, so I'm going to go to my AWS dashboard again, which is here, and EC2. Make sure you always use your own AMI, because AMI is going to be different for every region and every account. So I'm going to go to AMI section here and copy the AMI. So this is the AMI ID for Amazon Linux. I can choose Ubuntu if I want to. So I'm going to go with Amazon Linux and copy this AMI ID, paste it here. So let's say this is your infrastructure, you want to just create a single instance. And how would you go from here? You will open your terminal and run some commands. So Terraform has different commands. Let me show you all the different commands of Terraform. If I type Terraform, I will get all these commands. So you can see init, validate, plan, apply, destroy, console, fmt, force and lock, all this different, and you can read about them if you want to know what they do. So init command is to prepare your working directory, and this is the first command you should run whenever you start working with Terraform. It's going to install all the files necessary for the provider to run, and also it will also install the API access for AWS, right? This is why we define provider, so that we can get API access from our machine to the cloud. And then you will use validate to check the syntax if it is correct or not. You can run plan to check what is going to be created. So let's run all of these commands one by one to understand what they do. So as I mentioned, that first thing you are going to do when you work with Terraform is going to run Terraform init command. So Terraform init. So Terraform init is going to install all the files necessary. So just a second. Hello. भेज रहा हूँ. 122231. 231.
1222.
हाँ.
31.
हाँ.
Okay.
Okay, so you can see it says Terraform has been successfully initialized, and you may now begin working with Terraform. Let me make this small. Okay, can you see this message? And you can also see that there are two files created which we didn't create it. It's automatically done once you define Terraform init, and this is necessary for your code to run because it has all the information about the provider. It's not going to open here, but this is a required file, and this will come only when you run Terraform init. You should not make any changes in this. You should always make changes in file which ends with .tf. You should not touch any .lock or .state file. Okay. So Terraform init command is used to initialize the backend and provider plugins. We are going to see remote backend concept as well later on, but I hope you understood what is Terraform init command. It's used to prepare your working directory for other commands. First command to run every time you start working with Terraform. Okay. Next command we are going to learn is Terraform plan. It will tell us what is going to be created according to the code. So the code says we are going to create one instance, which is going to be this AMI, and instance type is this. Name of the instance would be this. So according to the plan, it should show us that an instance should be created. So I'm going to run Terraform plan here, and let's see what happens. It says one thing is going to be added, 0 is going to be changed, and 0 to destroy. So if you see the plan, you can see an instance is going to be created, which is .web, AWS instance .web, and this is the AMI ID. Then all the parameters here, this is the instance type, and the name of the instance is going to be hello world. Okay. So if you are sure that, and if you are okay with this plan, this is what you wanted, then you can run Terraform apply command. So you can see it says you didn't use the -out option to save the plan, so Terraform can't guarantee to exactly this action if you run Terraform apply now. Which means if you want to save this plan in a file, you can use -out command. So Terraform plan -out, and then the name of the file, let's say plan.txt. So if I run this command, it's going to show me the plan, and it will show save it in plan.txt. So if I do ls, I should see a file named as plan.txt. If I do cat plan.txt, it should have all this gibberish data, but it is what the Terraform plan, right? It can be any other syntax, not .txt. It should be .tf or JSON, which will show you the plan. But this is how you save your plan in a file. Okay. Hello. Alright, so you understood the plan option, right? Terraform plan command. It will show you what is going to be created, destroyed. You can skip forward a bit. I'll do all this. Okay. Alright, so I'm going to create this Terraform apply -auto -approve to create this infrastructure in my Terraform account, in my AWS account. So I'm going to go here and you can see an instance would be created. Yes, Terraform -auto -approve will avoid putting yes, or else it will ask you for the confirmation. So you can see apply has been completed and one resource is added. You can see the ID as well. So I'm going to show you that this is the hello world. It's the same what we wanted, and the ID is 0B85, which is the same. So this is how you can create infrastructure in Terraform by running Terraform apply command. Let's say you want to change something, you want to change the name of the instance, or you want to change the instance type. You can make the change here. Let's say hello world 101, something like this. If I save this and run Terraform apply again, or first Terraform plan, let's run Terraform plan to see what change is going to be done. So it will show us that one thing is going to be changed. And if you see this symbols here, this is plus symbol in green color, which means something is going to be added. And if you see this here, which is yellow color tilde symbol or the wavy symbol, which is going to show us that the name is going to be changed. So 1 is going to be changed, 0 is going to be added, 0 is going to be destroyed. So this is what we wanted, and I'm going to run Terraform apply -auto -approve to apply this change. So this will be done in like seconds. It's refreshing the state. Okay, so here you can see a file is created, terraform.tf state file. This file is very important for Terraform to work. This is what records everything, like every change you make or every resource you create. You can see the details here. This is very important for Terraform to work. If you delete this file, Terraform will not know what is happening in the cloud or in the account. So it will not be able to manage all the resources you have defined. So you should never edit, change, or destroy this file. So if I go to my console and if I refresh, I should see the change applied here. So without me managing anything from the console, everything is done through Terraform. This is how you create stuff in Terraform. So we have seen how to create a resource. I'm going to delete this for now and go ahead with other concepts. So Terraform destroy -auto -approve will show me that the instance is going to be destroyed. Alright, so let's go to this is what the workflow of Terraform is. First you write the code, which we did. We created provider.tf and instance.tf. Then we ran the Terraform init command, which downloaded all the provider files and the necessary documents. Then we ran the Terraform plan command to see what change is going to be applied or created or changed. And then we ran the Terraform apply command to create or to change the resource in the console. So write the code, init, plan, and then apply. This is also one of the questions that I got when I was sitting for my Terraform associate exam. So you should know the Terraform workflow. Then we saw all these different commands: init, validate, plan, apply, destroy, and we saw how it works. So yeah, validate command is what I didn't show you. Showed. So right now it's deleting, but validate command will show us. Let's say right now if I run Terraform validate, it will show me that the configuration is valid. But if I remove, let's say I remove this block here, it will then show me that this block hasn't got the ending thing. So you can see here it says invalid multi-line, and you can see it says no closing marker found for the string. So if I put the closing marker, then it will show me that the configuration is valid. So syntax check. Okay, then you can also have all these different commands which you need to know if you are sitting for the exam. But in real life you won't come across, like you won't be using this all the time, but this is something you should know. So here you have console, Terraform console. This is a command to run Terraform functions. So if I show you this Terraform console, it will open an interactive shell. So and it can do any functions. For example, if I do a simple like this addition, it will show me. So try Terraform expression at an interactive command prompt. Then I'm going to exit this. You have format. For example, Terraform follows this HashiCorp format. The equal to symbol should all be in same thing, like in same block, canonical form. Yes, so that can be done using Terraform FMT or the format command. Then you have force unlock. Sometimes when you run the Terraform commands, the state is locked and you cannot run your command, so you will use Terraform force unlock command. It will release the stuck lock on the current workspace, right? And these are all the different commands. So yes, so sometimes whenever, even though you're not trying to do any bad things, it still gets stuck, and if you want to release the stuck or the lock, you can do force unlock. So we saw this Terraform plan. It will create all the plans, and you can see the details about it. Then you can see the symbols, which means is it going to be changed or created or applied. Then it will also show us what is going to be added, changed or destroyed at the end. So we saw this earlier. Then we ran the apply command as well. Now let's see some meta arguments in Terraform. So we did this hands-on lab as well. Let's go and learn the meta arguments. So we are going to use the Terraform documentation for that. Terraform has different meta arguments, like just a second, I do have a repository which can help us. Okay. Can you see this GitLab repository on my screen? Yes, okay. So we are going to learn about the meta arguments here. These are all the nodes created about Terraform basics and foundational blocks. Let's see variables first before we go with the concepts. Variables are ways. Yes, I can send you this. So variables are ways to put your values. For example, here we are defining t3.micro, and we are defining AMI value directly in the code, but using variables you can skip that, and this can be used to reuse the values again and again in the code. So I'm going to create a file, name it variables.tf, or I can also do that in the same thing. So I'm going to create a variable for the instance type. So I'm going to copy this or cut this out, create a variable. To create a variable, you need to create a variable block. If you're using VS Code, you can install the extension to get this autocomplete. So when I write variable, it will create a block for me. I can give this a name, let's say size.com, or just size, not .com, sorry. So size, and the type is going to be string, default is going to be the value. So we have a value which is t3.micro. You can change it anything you want, t2.micro or anything, and description, which is optional. So this is instance size. Okay. So once you define the variable, if you want to use that in the code, you need to use var dot the name of the variable, which was size. This way, if you want to create multiple instances with the same size, rather than defining the value all the time, you can use variables. Other advantage is if you want to change the values from everywhere, rather than changing it one by one, you can change it directly in the variable. So let's try this out. So I'm going to run Terraform plan. It should show me that it is going to create a T2 micro instance. So Terraform plan is showing me that it's going to create T2 micro. If I make it small, the plan will change it to small, which means our variables are working correctly. So this way you can define variable for every different arguments, or if it can be used for long codes as well. I'll show you different examples. So you can see T2 small has been appeared here. Next thing you need to know is outputs. So I'm going to create an output here to print out the public IP address of my instance. So let's say you want to do some configuration here, and you want to SSH into this instance. So rather than going to the console to get the IP address, you can directly print it out in your terminal. This way you don't have to use the console, or else if sometimes you only have CLI access or not console access, you can use outputs to get the IP address or private IP, anything you want in outputs. So you can get all these different arguments that I mentioned here: instance type, key name, password data, public IP, private DNS. So let's try to get the public and the private IP. So for that you're going to use outputs, and you can we can see outputs option here somewhere. So we have variables and output values. So you can see here this is how you define an output. You have to give a name and then the value, what do you want to output. So I'm going to add an output block here. So output, name of the output is going to be private IP, and the value is going to be, so in the place of value you need to select the resource and the argument that you want. So I'm going to copy this from here, AWS instance. So I'm going to paste it here, AWS instance dot web dot public underscore IP, sorry, private IP. It can be anything, you can print out anything you want. So I'm going to add that, and I'm going to remove all these different arguments. You can use description, you can use sensitive if you don't want to show it, but I'm going to remove this. So save it and then run Terraform plan. At the end, after the plan, you will see that the output column will also appear. So you can see changes to output, and if I run Terraform apply, let's try doing that. So Terraform apply -auto -approve. Once the instance is created, private IP will be shown here. So this is what outputs are. You also have labs here which you can use. Next we have local values. So sometimes you want to create some local files. So using this block you can also do that. So let me show you an example here. S3 bucket. So you can see in this way you can give the name of the bucket by creating some functions or by defining some values directly here in this form. So when you define that, this local only work with the same file, within the same file. So if it is ec2.tf, it will only work in ec2.tf, and this is how you can create values for different arguments inside the same file. Alright, so next you can see here we have got the private IP. This way you can define public IP or public DNS, anything you want. Next let's learn about the meta arguments. So in Terraform we have different meta arguments like count meta argument, for each, then you have, where is meta arguments option? We are going to use the documentation itself to learn about this. So Terraform meta arguments. So there are different types, depends on count, for each, then provider and life cycle. So it depends on meta argument. Let's say let's consider an example of an architecture where you have AWS instance and you have S3 bucket. So you are creating a web page where people are going to upload some images, and EC2 instance is going to take the image from the user and store it on S3 bucket. So S3 bucket should be created before you create the instance. If that's the case, which means your EC2 instance is dependent on S3. So you can add the depends on argument in the EC2 instance to defining that depends on S3 bucket. For example, you can see here we have a depends on meta argument used. So this instance, this is an AWS instance created, and it depends on AWS IAM role policy. So this IAM role policy will be created first before the instance is created. To show you an example, let's do that. I'm going to create another resource in here. Let's name it S3 bucket. We're going to create an S3 bucket. So I'm going to use the Terraform documentation again. Terraform S3 bucket. So bucket can be created in just two arguments, like, or a single argument. I'm going to use just bucket, and this bucket name should be unique because S3 has a criteria where you need to use the unique bucket name. So I'm going to type something random. Alright, and in this I'm going to add an argument, meta argument here, which is going to be the depends on meta argument that you can see here. So I'm going to add depends on section, so depends underscore on equals to, inside this square brackets will always mean that it's a list. Even when you use security groups, it will be inside the brackets because an instance can have multiple security group, and so it should be a list of security groups even though you're using the single one. So depends on, I'm going to put that this instance depends on S3 bucket. So I'm going to copy this, and I need to destroy to show you this. So I'm going to destroy the instance that is created already, copy the S3 bucket ID, and then put it here. So once the instance is deleted or destroyed, we are going to run Terraform apply, and the S3 bucket will be created first, and then the instance will be created. And it does not matter what the order is, even if the bucket is down, like below this instance, it will still create the bucket first and then the instance. So you can also use this as a reference. I'm going to share this link as well for you if you want to. So if I run Terraform plan, it's going to show me that a bucket is also going to be created. So two things are going to be added, and which is bucket and, so let's run Terraform apply now. So you can see a bucket is created first and then the instance would be created. If I put this depends on part in this and saying that the S3 bucket is dependent on instance, it will then create the instance first and then the bucket. So this is what depends on meta argument is. Next you have count meta argument. So count meta argument can be used when you want to create a resource multiple times. So showing that as an example, let's say you want this instance. Right now it is only creating a single instance, but if you want to have 5 instances of same configuration, which means same ID, same size, which is t2.small here, then you can use count meta argument. So you can see the example here. We have a resource block for AWS instance. The count is set to 4. AMI ID is this, and the instance type is t2.micro. So once you run this application, once you run this Terraform code, it will create 4 similar instances with same values. So let's wait for this to come up, and then we can add an argument which is going to be count equals to 3. So right now we have defined everything same, so even the tags would be same, which is hello world 101 for all the different 3 instances. So let's save this, and if I go to the console, in here I will have a single instance t2.small with hello world 101. So this is the one, this one is previous one which is terminated, but you can see hello world 101 which is running t2 small. And if I run Terraform apply now, once I have mentioned the count equals to 3, it will show me that 2 resources are going to be created. So 2 more resources will be created because one is already there, and Terraform state right. Okay, this is also showing us a problem because we have defined an output here. An output is defined when it was just a single instance. So now that you have 3 different instances, you need to define for which instance do you want the private IP. So here it is asking to define the count.index. So what do you mean by count.index? Right now we have defined count as 3. So every instance will have an index value, and index starts from 0. So the first instance will be 0, then the second instance will be 1, and this third instance will be 2 index. So if I want to get the private IP for, let's say, the second instance, so I'm going to define the count here as 1 in square brackets. So AWS instance dot web for 1 dot private IP. So if I save this and run Terraform plan again, it will not show me the error. Every time you get an error, just read the message carefully and you will get to understand what the answer is. So it's just asking you to add the in count.index. It says 2 things are going to be added, and then it will change the private IP as well. So you can see changes mentioned here. So I'm going to run Terraform apply, and I should see 3 instances created in my account, and here they will all have same name, but you can use count.index to change the name as well. Let's wait for it to complete. So right now it's in creating state, and after some time it will come up in running state. So count will create resources with same configurations, but if you want to have different configurations, you can use another meta argument in Terraform, which is for each meta argument. So for each meta argument will create different things when you define it. So for a group, the region should be East US. For another group, it should be West US. So you can define the for each meta argument, and you can define key and value. So like whenever it is a group, the region should be East US, and whenever it is another group, it should be West US. So for each key, each value. So name is a group, and then the value is going to be East. So this will create 2 resources with different set of arguments. We're going to see that as well. So let's wait for this to come up. Right now it has created 2 resources for us. So 3 instances created using count meta argument. If I refresh, I should see that. So all of these are same name, hello world 101 101 101. But you can change that. You can add the count.index. So count.index. When I apply this, it will have hello world 1, hello world 2, hello world 3, or it will have hello world 1. So you can add +1 here to get, because count will start with 0. So if I just put this, it will start hello world 0, hello world 1, hello world 2. If I add +1, it will start with 1. So I'm going to run Terraform plan first. So you can see the index is 0, 1 and 2, but if I add +1, it will then change the name. So you can see it's 3, 2 and 1. So this way you can also use count.index inside the arguments to make changes inside your code. So this was count meta argument. If I want to have for each, like if I want to have different values, I can use for each meta argument as well. We have different provisioners in Terraform. There are 3 types of provisioners: remote exec provisioner, local executioner provisioner, and then you have file provisioner. Provisioners are used if you want to do something, some task or some actions, and these are recommended to use as a last resort. So provisioners can be used to model specific action on local machine, on remote machine, in order to prepare servers. So you can use this for installing anything on your remote machine, let's say EC2 instance. You can also do that to install something on your local machine like config tools, yes. Or you can also use it to run a configuration management tool. So to show you an example, if I go here in my code which I was showing you earlier, we have used Ansible. So you can see this is an example where we are using some modules. We have different modules present here. So this is a module block where we have modules for Cassandra, EKS, Helm, RDS, VPC, and I created this inside each module. I have defined instances, variables and output for that module itself. For example, in VPC module I have everything related to VPC, creating a VPC subnet, internet gateway, route table, all of this. Then I define my outputs and variables inside this. In RDS I have configuration for my database. So we are using provisioners here inside Cassandra, where we are creating some EC2 instances. So if I go to main.tf, I have an instance created. So this instance has provisioner mentioned here, which is remote executioner provisioner, remote.exec provisioner. So you can define inside this remote provisioner, I'm using inline method to run all these commands. So I'm running a command which is to echo this part in this file, then put all of these in this message because I want to run Ansible tool. So if I go below here, you can see whenever you use provisioners, you have to create inventory. Yeah, this is required whenever you want to run with Ansible. You need to have a host inventory where you define all the IP addresses on which you want to run the Ansible playbook. Then whenever you define provisioners, you need to define the connection block. So yeah, you can use a shell script like this, or you can also use shell script. If you're using EC2 instance, you can use something known as user data. User data is used to bootstrap the script, like bootstrap your instance, and you can define the script. So I have a script named as ansible.master.sh. So if you see here, this is the file, and I have a shell script created to create this user, add this user, install ssh pass, run this, and install Ansible on my machine, on my remote machine, because once I create this Terraform, it will not have Ansible installed. So I need to first install that, and I can use user data for it. Once the Ansible is installed, to do things, I can then create provisioner, which is remote exec provisioner, and run all these commands. But provisioner also requires something known as connection block. So connection block will be how will you connect to this instance. So this is going to be type SSH. You have SSH and WinRM. So if you want to connect with Windows, you're going to use Windows RM or WinRM. But this is a Linux Ubuntu instance. I'm going to use SSH. User is Ubuntu, and this is a private key file for SSH access. Then the host is going to be self.public, which means public IP of this instance. And this way it will run all the commands, because the connection will not happen between them if you don't have connection block. Next, I also have an example of provisioner, which is file provisioner. So if you want to, let's see all the provisioners here. So file provisioner, local exec, and remote exec provisioner. So whenever you use a provisioner, you need to define a connection block. So most provisioner require access to remote resource via SSH or WinRM, and you expect a connection block with all these details on what is the type, then what is the host, user, password. If you know the SSH command, you use SSH-i, the key name, user @ host. So this is what it has all the options as well. Then we saw file provisioner. So file provisioner is used to copy files. So if you have something from here, you can copy it to remote file. So you can see I have a file named as engine-config, which is the playbook file, Ansible playbook. So I want this to be copied to my server, because if it is not on a server, it will not run the playbook. So I am going to first copy the file. So here I am using the file provisioner to copy it from my local machine, which is path.module. So engine.config is here, and it will be then passed to destination, which is home Ubuntu, on this server. So I also need a connection block for this. So I've used the same connection block here, and then I'm going to pass my role directory. So not just file, also the directories can be passed through file provisioner. Right, so I'm passing the whole directory which has task and templates inside it. Same, you need to pass the connection block. Once you do that, then I'm running the remote exec provisioner to run the playbook. So I'm using the Ansible playbook command to run the playbook command on my machine. This is how you will use the provisioner block. So file provisioner is used to copy files or directories from machine executing Terraform to the newly created resource. So it can be AWS EC2 instance or Azure Compute Service or Google Compute Service. So file provisioner also supports both SSH and WinRM for connection block. Then you have local exec provisioner. So I also have an example for that. Local exec provisioner, let's say you are doing something with Kubernetes and you want to apply a file on your local machine, because the cluster access is in local machine. So you can use local provisioner to run the commands on the same machine. Let's say I want to create some file, so I'm going to use the local provisioner. So I have a local provisioner example here. So if you have worked with Kubernetes, you might know concepts of namespaces, or even if you don't know, that's okay, because local provisioner is just used to run the commands in your local machine. Yeah, so Kubernetes is container orchestration tool where you define, okay, you do, all right, no problem. Let me show you the local provisioner. Local exec Alright, so yeah, here is an example which is something you will also relate with. So we are creating a file. We are creating a key pair in AWS in the Terraform to put the key name here. So we are directly creating, and whenever you create a key pair in AWS, if you try to use it with SSH command, it will show you an error saying that the permissions are not correct. So you need to define the permission, which is chmod 400, and then the key pair. So we are also doing that here. We used to do it here. And to do something in your local machine, you can use local exec provisioner. So here's another example where we are doing the config, updating the context of the cluster so that we can get the cluster access. So we run this command, and then same, if I want to set the image, I'm running some kubectl and helm commands in my local machine using this. Right, you can see it's using kubectl create ns, create namespace, cert manager. So all these commands are run in my local machine using local exec provisioner. Okay. And then data block. So yeah, there's something data block. Let's complete data block and then we can stop. So same code example. Let me show you the example here. Data block is used whenever you want to get something from the console. For example, we used to type the AMI ID directly, but you can also define a filter. So I have a data block here for my subnet IDs. So you can see this is an provider defined here. Inside the provider, I have a region which is defined in variable. So where is the variable.tf? I have defined a region US West 2 Oregon region. So inside Oregon region, we need to check how many availability zones are there. So if I want to get the information, I can use data block. So I'm using data blocks to get all the AZs, and then I'm creating the subnets all in one by one. Like I've defined 3 as a count, and then I'm using creating the subnet in each of the AZs. So US East 2A, 2B, and 2C, like number of node, like whatever is the number. For example, if I go to my in here, if I go to VPC section, so whatever information is there on the console, if you want to get it on the Terraform, you will use data block. Here is another example where you can see it's getting the information about the AMI. Your sharing is frozen. Now can you see? Okay, all right. So here is another example to get the data about all the AWS AMI. So we have defined that we want to get the AMI ID for Ubuntu. So if you don't want to use the console to get the AMI ID, you can define it in the block. So you have defined the data for AWS AMI. The filter name should be this. Then the virtualization type is this. So if I go to my EC2 instance, you will see all these options for the particular AMI. So let's go to launch instance option here, and then click on get browse more AMIs option. So you have, if I go for Ubuntu, let's search for Ubuntu. And then this example. Okay, yeah, here is. You can see here we have defined the filter name should be this, virtualization should be HVM, owner should be this. This is canonical, the owner. And once you find something which is filtered out this, then put the ID here. So data.aws ami.ubuntu.id. So whichever AMI has all these filters will be entered here. So you don't need to go to the AWS console to get the ID. You can directly define it in the code using data block. So if I show you the documentation data, so data block requests that the Terraform read from the given data source. For example, we used the AWS AMI example here. So it will read the data from the console to the Terraform block and export the result under the given local name. So here is data block to create to get the AMI, which would have the name as app server, and it is created by you. The AMI is created by you itself, so it says owner itself. Okay, then remote backend. Do you know the concept of remote backend? Hello. Yeah, am I audible? Yes. So do you have experience doing that? Because this is very important. When we Yes. So to when you will be defining that in the Terraform block, which we were using to define the AWS or the provider version, same block you will define the backend. And before you define the backend, you need to have S3 bucket and DynamoDB table created. So DynamoDB table is used for state locking. You can see here, whenever you state locking, let's say there are different people working on the same code. So whenever someone run Terraform plan or Terraform apply, the state file is going to be changed. So if multiple people try to run the same command at the same time, Terraform state is going to be corrupted. And to avoid that corruption, we have a lock setup. So we have something known as Terraform state.lock. Whenever you run, it will be applied here. You can see a file named here. And this is not possible if you don't use DynamoDB. So it is going to be used for Terraform state lock whenever someone applies, so that the Terraform state should not be corrupted. So this way you can use S3 bucket and DynamoDB. There are various benefits for this. This way you can use encryption on your S3 buckets to keep your Terraform state file secure. You can also version them. You have versioning option enabled on S3 bucket, so you can have different versions of state files. So if there's any problem, you can revert to previous state, or you can see what changes were made. So to enable this, you need to first create the bucket and then define the Terraform backend block inside the Terraform block. So you have different options like S3, and you have options like Azure Blob Storage, and different options, Google Cloud Storage, something. But if you're doing it on AWS, you should always use S3 because it has more options like encryption and everything else. So if I comment this out, first thing I need to do is to run Terraform init command. It will not work if I don't use init. Once the init is done, then, because if I run Terraform init, it's going to say something. For example, if I run Terraform init now, it says initializing the backend, right? And it is now blank because we have commented it out. We don't have any backend block right now. But if I comment it out, then it will show me that the backend is working. And then if I check my S3, it will have a bucket created which will have the state file as well. So it will be transferred from here. You can choose to migrate everything. Right now it does not have anything here, but if I enable S3 backend on here, everything that is present can also be transferred, or you can also choose to have like fresh. But I would recommend you to push it like everything, because this way you will be able to manage the existing resources through S3 backend as well. So this was a backend on S3. Then modules. So just a second. Alright, let's go to modules for now. In Terraform, you will have modules for different blocks. So rather than you defining anything, there are modules for everything created already. So let's go to Terraform modules registry. So you have modules for VPC, which is used 32 million times. Then you have Cloud Post modules for IAM security group. So you can use these modules directly rather than creating your own code. When you use these modules, you have to define some values, and you can use these modules this way. You have the code directly present here. This is similar to what you use whenever you create your own modules as well. So if I show you the modules block here, right now we have modules created for Cassandra, EKS, RDS, Helm and VPC, right? This modules won't work unless you have main.tf file, which is used to call the module. So we have defined the modules here, but we need to call it from here. So you call it using the module block. So module is going to be VPC, source is this, so it is in current directory under modules under VPC. So you need to define the source. Here we are using the source as this because it is defined, because we have created it ourselves. But if you use something from Terraform, it's going to be Terraform -aws /security group /aws, because this is the path, right? And if you want to check the code, you can go and check it from here in the GitHub. You can open it in web editor. If you want to check anything, you can check it, or you can clone it to have your own customized Terraform module. So whenever you use modules, make sure you're calling it in the main.tf. And you can also have, for example, one challenging thing that I experienced when working with modules was, let's say I have VPC and I want to create this instances in this module from the VPC that I created here. So I want to pass my VPC ID from here to this module. So passing the arguments from one module to another is complex, like if you don't know. But if you know, you will be able to understand. But let's say how I will pass it. So if I want to pass, I will create a variable, but I will not give it a value. So in here, if I show you, first I will create an output. So I'm going to output my VPC ID and my subnet ID here, and then inside this Cassandra I'm going to create a variable which will fetch the output from here. So I'm using subnet and VPC ID, right? So here a variable is created to VPC ID, but I have not defined any value to it. No default option is present, correct? Yeah, so just hear me out, it will be easy for you to understand. So let's say I have created a VPC in my main.tf here in the VPC block, and I have three subnets. So I created a VPC. I want this VPC ID and the subnet ID to be used in this RDS block and this Cassandra block where I'm creating my instances and my resources. So if I want to pass it from VPC to Cassandra, so I will first create an output for VPC. So you know how to create an output now, right? So I will create an output where I will define that I want to output my VPC ID. So when I output my VPC ID, I will create a variable in here because I want to fetch this VPC ID. So I will create a variable, and then I will not provide any default value because I want the value from this part. So once you create this, no, it will not automatically pick it. You will define it here in the main.tf. When you call your modules, let's say I'm calling the modules for Cassandra. So I have a variable created for VCS subnet VPC ID. So it will tell me that the VPC ID should be called from module, from this module, which is .vpc, and then the output name. The output name, which was you need to create a variable where you want to call it, right? So here you can also see we are getting the VPC ID here, but it will not work unless you call it from main.tf. So inside the main.tf you will have a section where you are defining your variables where you didn't have any values entered, and you will tell them that the value should be from this module, the module name and the output name. So module name and the output name. Same here as well, which where you are using in AKS. Okay. Okay. Yeah, so I can choose to skip, I can choose to remove that, but I'm just putting the cider here, and I'm actually getting the value from variables.tf here, right? So that is why I've defined that in here that the VPC cider should be variable dot this. So the variable is present here. So I have some variables created outside the modules. Cider is just a value which is used yes, yes, yes. Let me explain if that will answer your question. I'm not sure, but this is a VPC module. Okay, inside this module I'm going to create one VPC, 3 subnets, internet gateway, and route table association, all these things. So I'm going to create a VPC with the cider module, cider block as 10.0.0.0/16. okay, so I've defined that the value of the cider block should be from variable which is this cider. So I've created a variable inside my module. Inside this module I have created a variable named as VPC underscore cider, but I have not given it the name. I have not given it the value. This value is commented out, so it's not picking it from here. So right now my VPC does not know where is the variable coming from. Same as we did for Cassandra, we didn't define the value. We didn't define the value for VPC ID. We just gave it the type. So I gave it just the type, and when I'm calling my module in the main.tf module VPC source is this, I have these two options where I haven't given the values yet. So it will get the value from the variable. So variable now is using this block outside the modules, right? So here I have some variables. So I have defined a variable for cider block, and this is the variable. So it's going to put the, if I don't use this, it's going to show me an error saying that the variable VPC cider is not defined yet. Why are we using this variable? Yeah, just like an output. So I can choose to directly give it from here and then skip calling it from here, right? I don't have to then call it from here. Yeah, that will work as well. I don't want to then call it from here. I just need to define source and cluster name. Then again, if I want to just have the cluster name defined inside my module, I don't want to call it outside my module. So all these values that are called are the values that are not defined yet. If they are defined, then they don't need to be called here. Yeah, there can be a chance where you just have modules with source, nothing else. Right? Even when you use this modules from the Terraform, all these different modules from the Terraform, you need to define the values. If you're using module for AMI, for EC2 instance, you will define the values for AMI, for anything, for instance type, for key name, and everything else. Okay, so it's more than 1.5 hours now, and I need to go to pray. So we can continue with 1 hour session later on. You can do the payment on Fiverr if you want to, or you can use, if you have downloaded that Remitly, let me know. Yes, I'm going to share that on this chat. Okay, so you need to copy this or else it will be gone once we stop this meet.